very good. So with this introduction, I'm not sure I have a lot more to say, actually. So I'll do my best. Thanks for crowding in. So we're going to talk about architects and architecture. And architecture is a little bit of a strange animal, right? You ask 3 different people what architecture is, and you probably get at least 3 different answers. And a lot of people will also say that architects are also kind of special animals. So when we as IT geeks think about architects, the first character that often comes to mind is this one, right? The chief, especially the chief architect, right? So this is the person who knows everything, who makes all the decisions, who has the ultimate authority. There's one catch, though, and that is, this architect is actually not a human being. This architect is a computer program, right? Because we know the matrix, this is part of the machines. So this doesn't work extremely well. There's another very strange architecture figure that's made it into the movies, and that is Anthony Royal of the very strange movie High Rise, right? And this is, the ultimate persona of having an ideal, almost like an illusion that they're building, and it goes totally, absolutely, awfully wrong and haywire. So definitely some similarities here with some architects. When people see me as architect, though, they think more about this guy. Right? It's like the mad scientist, and it has a little bit to do with the haircut. It also has a little bit to do with the car I have, right? And I think a little bit of mad science in architecture is actually fairly well placed. So all jokes aside, though, I want to talk a little bit more about what different view I have of what architecture and being an architect in a modern or large IT enterprise means. And in order to do that, we first need to understand what's actually going on in a large-scale modern IT. So let's start with that, right? How does the role of IT fundamentally change? First, I have a tiny bit of a soapbox I need to get on, and that is the word digital. We always talk about digital transformation, digital disruption, digital giants, digital revolutions, right? Everything seems to be digital these days. The catch with that is actually that we made things digital like 30 years ago. Right? We replaced letters with email. We replaced paper calculations with spreadsheets. We replaced our watches with these funny things that never show the time unless you push a button, right? So those are the things we're done with making stuff digital, right? We replaced the tape with the CD, right? We've been there, we've done that. So it's no longer about making more stuff digital. It is actually about really understanding how we can use the digital technologies to fundamentally change the model. This can be the model how we go to market, the model how we make money, the model how we interact with our customers. So the digital world is a little bit of a misnomer. We're not looking to make things digital anymore. We're looking to change the model how we operate and think about our business thanks to digital capabilities. A perfect example of that is, here's a digital product. Very nice, Microsoft Encarta. It's an encyclopedia. Right? And it was actually much better than any paper encyclopedia, right? It's like more content, more up-to-date, more searchability, multimedia stuff in there, easier to carry, right? So better than any paper encyclopedia in all regards. Classic digital product. Now, who uses Microsoft Encarta? Interesting, right? I did use, right? It was a great product, but somehow this came and went. And of course, the answer to what do we use instead is fairly obvious. That is Wikipedia, right? And this is the difference between making something existing digital and changing the model, right? Wikipedia realized that with a global network and a global browser and all these kind of capabilities, you can fundamentally change what it means to be an encyclopedia. Right? It's no longer the people in lab coats, like a few authorities that write down whatever they can, but rather it becomes a collaborative model. And this is a perfect example of making things digital versus changing the model thanks to digital capabilities. Now, translating this into IT, though, we find that there's a lot of assumptions built in the current way IT operates. Because IT, corporate IT, also became big by making things digital. And what did IT always do? IT took an existing, largely manual process. I worked for an insurance organization for a long time. You have new customers, you have risk calculations, you have claims, you have payouts, right? You have all these kind of processes that basically already existed. And then IT made them digital. And they were faster and better and cheaper and all these kind of things. And to be honest, IT has done pretty well for itself doing that. Many large organizations have IT budgets in the billions of euros, basically making things digital. But as we already learned, it's not about making existing things digital, it's about changing the model. There's a catch though, because the IT is so used to making things digital that they work on a model where it's always an as is and a to be, right? And we call that a project, right? Like we know where we are, we want to be, we make a business case, right? And up here is something different. That's not the project. This is the giant sigh of relief because finally the project is over. Hold on, my clicker, my ultimate weapon is failing me. No! What's happening? Can we? Ah, there we go. All right, I'll try. Right, this is the big sigh of relief because finally we're back to normal. And back to normal means there's no more change, right? We package the change ever so tightly into these projects with all the controls and steering committees and budget reviews, like anything we can imagine. And the big celebration is actually when the first user usually uses the product, right? We celebrate before actually anybody really uses it because we're done with change. Now, the digital world, as I might have hinted, is working slightly differently because we're not making existing things digital. We're looking to change the model. The question is, of course, what's the new model? The short answer is, well, no one knows because we're innovating. And that means we need to actually prepare for an environment of constant change. And as we see, this is not a play of words. The left-hand side basically assumes that normal is no change. On the right-hand side, change is normal. It's a constant change. And it becomes hard to make business cases because you don't have a clear to-be state. And that requires IT to work fundamentally different, right? In the left-hand side, we were in the business of guessing well and guessing right. We're going to build this thing, and we're sort of anticipating a big return because we make something better. And if we replace something existent, that's actually kind of doable because you know what you're aiming for. On the right-hand side, it is not about being a good guesser. On the right-hand side, it's about being a fast learner. And again, those two things are basically exactly the opposite of each other. And I call the left-hand side the economies of scale because when you run these projects, the bigger you are, the wider you can deploy the results. Generally, the more returns you get. On the right-hand side, it's economies of speed because if you need to learn fast, it's the faster you can move, the better off you are. Now, there's a very important nuance here as well, and is you will find that the people on the left-hand side speak in absolutes. They speak in budgets and timelines, right? It's going to take 6 months. They're going to take that many $1 million. The server's going to cost 50,000 euros. They speak in absolutes. The folks who are here, if you're in constant movement, if you're always changing, absolutes are no longer that meaningful because the next second it's going to be different. So you realize that the folks on the right-hand side speak in relatives. They speak in burn rate. They speak in consumption. And if you think about it, why, for example, the cloud model is so successful is because the cloud model speaks that language, right? Cloud is not moving servers to another data center. I mean, Google and Amazon's data centers are pretty nice, but they didn't exactly invent the data center. Right? We had data centers and servers, everything before, right? So it's not about building another data center. What cloud really did is change the consumption model, right? It's not 50,000 euros for a server. It's $3 an hour. And you realize that the folks on the right-hand side who think in burn rates and consumptions because they live in constant change, that for them the cloud model is a totally natural fit, and making an upfront investment for them doesn't fit very well. And that's why all organizations that are thinking in the right-hand side model are essentially in the cloud because that's the way they grew up. So I have a relatively long list here. I'm not going to read through this, but the economies of scale versus economies of speed are basically diametrically opposed. Well, they're the exact opposite of each other. On the left-hand side, you know what you're going to do. You can make a nice plan. Variance is unwelcome. You're optimizing, right? On the right-hand side, you're doing exactly the opposite. You're experimenting. You actually want disturbance. You want variance. You're testing hypotheses, right? Failing is fine because it's learning, etc. And here we think in rates and consumptions. On the left-hand side, we think in absolutes. So that adds context about how the role of an architect changes and how the role of IT changes. The old IT that is basically automating existing things is important, but important has two dimensions, right? Important is how critical it is that it exists, but also how much of a differentiator is it for your business. And the classic IT is important in a sense, it's like electricity, right? If the lights go out right now, kind of a little bit of a hassle. We sit in the dark, nobody likes that. That's IT. We're glad it's there, but where the electricity comes from doesn't make a lot of difference. Where the IT comes from doesn't make a lot of difference. So in the new model, right, if you're experimenting, if your new business models, come out of the IT, then the IT becomes a differentiator. The way I explains this when I worked at Allianz, I often said, hey guys, we had 127 years to find all business models that didn't depend on technology. And you know what? We did a pretty good job at it, so I'm pretty sure we found them all. But if you use that logic, right, all new business models that are coming now are going to be IT enabled. Right? And Allianz and other insurance companies know this very well, and that means IT is a substantial differentiator for them. So that's the context, right? Digital world, the so-called digital world, not about making digital things, but about changing the model, fundamentally questioning sort of how the IT operates. Change is now normal as opposed to abnormal, and the role of IT becomes a differentiator as opposed to just being a parity or a commodity. So in this environment, now our architects are living. And I feel that the role of the architect in that environment also completely changes. And what I see as the most important task of the modern architect is to be a connecting element. And that's what the architect elevator is. If you look at traditional organizations, they just have a lot of different levels. There's a penthouse up there, then there's the sort of the upper management, the upper middle management, the middle management, the lower middle management, the upper lower management, and down here is the working student writing software, right? It's like the intern. The intern doesn't have anybody to pass it on to, so they actually write the software. And at the end of the day, that worked okay for them because we know this model is kind of a nice separation of concerns, right? So the CEO doesn't have to worry about where the intern is sitting writing the software down there, which intern it is. However, if there's movement in the system, like we already said, right, it's economies of speed, all this layering leads to some issues, right? It takes time for things to travel, and you have translation errors. You get the telephone game, right? CEO says something, by the time it ends up at the working student, right, it might be something completely different. So if those things are out of whack, basically nothing else can save it, right? The most efficient and the most well-run IT project isn't any good if it's not actually connected to the penthouse in the business strategy. So you need to get this connection right, otherwise nothing else can save you, can help you, right? So we need to connect the penthouse and the engine room, and now we have to deal with many different layers, and that means we need to look at technology, but we also need to look at organizations. Interestingly, what we find out is that complex technical systems don't behave all that different from complex organizational systems. So architects have an edge there because they know how to deal with these systems, and I'll give some examples. Now, the elevator doesn't imply telling every floor what they want to hear, and the story is completely different. Now, that doesn't help either, right? That's called like charlatan, I guess, right? That's not architect elevator. So you need to share the same story, but in a different way, right? You need to make it connect and translate it on the different levels, but it's gotta have the same basis. You can't make up different stuff on different floors. That doesn't make any kind of connection. So what this looks like in reality, what does an architect like this do? Here's some examples, right? It starts with business and IT strategy. As I said, if those don't line up, nothing else can help you. You're always looking to make a change because you're really trying to get these organizations to be more digital, faster moving, agile, lean, etc. Complexity is probably your biggest enemy in this, right? The IT stuff we have is complicated and complex. So making that connection isn't easy. So you need to be a good communicator. Secretly, we architects, we always like everybody else to know how complicated our stuff really is because we want the other people to suffer a little bit with us, right? Well, it happens, right? That doesn't work very well here, right? You gotta make it easy to understand. You gotta make it simple, but not simplistic. Right, and then down here in the engine room is also a lot of good stuff to do. Christoph talked about resilient systems, taking friction out, lean, agile kind of things, and keeping up with the technology. So in the end, I measure the value of an architect really by how many floors can they cover, right? So the more floors you can cover, the more valuable you are in this context. Now somebody might say, Well, why don't we flatten this building, right? The so-called digital companies, they basically live in a bungalow, right? They don't have all these layers, right? So one idea would be, well, why don't we just flatten this thing down a little bit, and then we don't need all this elevator-y kind of stuff. Now, the problem is, if you take a high-riser and blow it up, you don't get a bungalow, you get a pile of rubble, right? So that doesn't work. So the next best thing you can do is be the connecting element, because you're not going to get rid of all those floors as easily. Sounds great, but in reality, there are some challenges, some dangers of riding the elevator. And that is, because this has been working for decades like this, the system has optimized itself in a certain state. And that state can be described as follows. Management lives in an illusion. Well, they think, all they hear is we have the latest Docker Kubernetes, we're going to the cloud, we're using Spark and Flink and Beam and whatever all, right? They hear all these great kind of things out of the engine room, and they're quite happy living in that illusion, right? Yeah, because it sounds great, right? They never go, they never actually look what it looks like, right? Never open the hood. Meanwhile, IT actually enjoys a fair amount of freedom because, you know what? All the middle management has no idea what they're doing anyway, right? So they actually do get to play with Apache Beam and Flink and Spark and all the other stuff, right? And nobody actually sort of expects a lot from it because, there's no connection. Well, how can this actually work? Well, the answer is very easy. There's like 12 levels of ignorance. That's what makes the miracle function, right? There's, we call this decoupling. Right? It's one of those architectural traits I think Christoph spoke about, right? It's loosely coupled. Now, in this case, decoupling is not exactly what we want. Now, our freshly minted elevator architect comes in and says, cape on, right? It's like, I'm just going to zoom across these levels, right, from beginning to end. Now, the problem is you're going to make all three parties equally unhappy, right? Right? Because you take the illusion, right? You take the freedom, and, well, I don't know what you do with them, but they're definitely not going to be, happy, right? Once you zoom out, though, right? Yeah, so you give them irrelevance if you're a little bit mean, right? So, but you can see that from a systemic perspective, right? You give them transparency, and that's actually a good thing, but they're not happy about losing the illusion initially, right? You give them some governance, which is actually also helpful, but initially they're not going to be happy because they enjoy the freedom. And I don't think these guys are going to be very happy, getting irrelevance shown because they need to really find their place. What that tells us, though, is that bringing change into these complex systems is not an easy task, right? Because they locally optimize themselves into a state where once you bring a connection in there, you make them all equally unhappy until people can actually see that something better comes out. And that's why change and transformation is actually so difficult to do. And that's the key role of the architect, right? If you want a change to be digital, right, that nut we need to crack. Now, what does that look like, right? What does one of those architects look like? And I'm just going to give a few glimpses, right? I have a whole book and website and other stuff. So I'm going to give a few glimpses of, sort of what's going on with the architect up in the penthouse, sort of the mid-levels, and the engine room. One thing that architects can do in the penthouse is they can look at the organizational structure and actually understand the digital maturity of this organization based on the org structure, because they have their architectural thinking and apply this to organizations. And one very interesting aspect is, where does a CIO report into? Well, because ultimately the IT rolls up into a chief information officer. It's not an easy job. So evil people always say it's called career is over, but I don't like that too much, right? So there's some jokes about the CIO titles, but it's actually a quite tough job, right? Because you're supposed to be cheaper, more digital, innovative, deliver faster. Basically, no business has ever complained that the IT is too fast or too cheap, right? So a lot of pressure. Now, interestingly, when a CIO reports to a chief financial officer, that means that the far zoomed out view of the IT is a cost view. Right? Because what does a CFO largely care about, right? A CFO writes the checks, or rather not, right? So because they need to control the spend and the cost. And that means the key vehicle, the key lever you actually have is cost cutting. And if cost is the main metric, the right thing to do, Yeah, not the thing we like, but the right thing to do is to outsource it, right? If it's cheaper done somewhere else and cost is your main metric, then that is the logical right thing to do. Now the question is that the right assumption, right? And you'll find that other organizations, they have a chief operating officer. I sometimes call them the chief optimization officer, right? Because they're going to make sure that the whole shop runs quite well. And that is a big step forward, right? Because here you're looking to invest in the IT and get a return on investment. The way I explain the difference is, here you don't take your car to an oil change because it costs money. Here you very much do take your car to an oil change because the return on investment is extremely high. So it's a big step forward, a big difference. Yeah, and there's a lot of things about harmonizing, rationalizing, bringing the IT centrally in the group, getting more standards, all these kind of things, and that is to harvest the economies of scale. Right? If you have too much fragmentation, you don't get the economies of scale. If you harmonize, standardize, rationalize, you can do that. So big step forward. Now, interestingly, on the right-hand side, gotta get my weapon here working. Let me see. Oh, interesting. Is that what Christoph also complained about? Oops. Yeah, exactly, technical debt. All right, let's see how I get this gets back working. So if you're looking at the right-hand side of the equation, it starts to look a little bit different. So often we have a CDO, which is sort of the CIO's alter ego, right, a chief digital officer, and it's a dangerous game, right, because they're supposed to be sort of the CIO then does the old IT and the CDO does the new IT, and that leads to also very strange dynamics, but it's often sort of an escape maneuver. And often they bring people in-house and try to be more agile, right? So in the end, they're trying to do good things as long as they don't create a lot of conflict between the two. And then ultimately, you find enterprises where the IT is part of the board like any other function, right? They report to the CEO, and that means that they don't see IT as like a sort of little thing machinery in the engine room, but they see IT as an equal function to the other things, to sales, distribution, product, etc. IT is an integral part of what they do, and in the end, they also take this big distinction between IT and business out. Right? And you see quite a few CIOs who actually do change reporting lines, and it's almost always in the right-hand side direction. I know quite a few large enterprises I worked with where they used to be here and they moved here. Oftentimes, they also move here. Many organizations have a CDO, etc. So there's definitely movement in the system. So a modern architect can understand these kind of things, right? They're not random. They're not sort of haphazard. You know, this is really a sign of how the organization ultimately thinks about the IT. And as I said earlier, if things are not lining up here, then nothing else works, right? If you have folks who are only interested in cost, and you try to sell them continuous integration and Kubernetes and Spinnaker and all these kind of things, right? If you try to sell speed to somebody who cares about cost, that is not going to work. Right? So if you want to ride the architect elevator, you can do one of two things, or both ideally. You need to adjust your message to based on where you are, but at the same time, you're also trying to change the way people think. You're trying to nudge people over. But if you try to sell speed to people who care about cost, that has the classic effect of the architect saying, oh, management doesn't get it, nobody listens to me, right? They don't understand, right? Those is the classic complaints you're going to get, but in the end, you're just trying to sell something they're not interested in. And you can either make them interested in it, or you can sell them something different. Otherwise, you're going to be complaining for an awful long time. So this is one great example about how architecture thinking applies to businesses up in the penthouse. I have another one, and this is probably my most architectural slide. All architects, well, this is architecture. Who said architecture is difficult? Right? It's like, oh, you know, architecture always has boxes and lines. We'll hear more about that later. So this fulfills our definition of architecture. It has boxes and lines. And this is a very common pattern we know, right? In computer science and architecture, this is called layering. In fact, many people say that computer science is the field where every problem can be solved by one more layer of abstraction, right? So we like making layers. And that's not because they're so much fun, but because they're actually useful. You know, layers separate concerns. Right? They abstract details. They make clear dependencies, right? Dependencies only flow one way. So if I want to replace something, it's easy to take a piece out, and it's easy to put another piece in. The interfaces are well defined, so if I change the implementation behind it, the interface doesn't have to change, and the other parts don't have to change either. Well, a lot of great benefits. Now, if you think about it, though, these benefits apply to organizations just equally well. right? It's like separations of concerns, right? It's like, I don't know all the financial tax codes, right? The finance department does that, right? There's a separation of concern. What do we call replaceability? Outsourcing, right? We're taking a layer out and replacing it with a different implementation, trying to keep the interfaces intact. That is a classic outsourcing. And as most people know is, if there's too many dependencies, if there's too many lines going on, that makes your outsourcing generally not work terribly well. So having clean dependencies and clean interfaces helps outsourcing. So organizationally and technically, this is actually exactly the same. And interestingly, these are the reasons why large organizations live in the skyscrapers. They did layering because these things work well for them. They have a giant organization to run, so separating concerns and abstracting details. You know, they do like to outsource or replace or bring externals in, right? So they actually benefit enormously from this layering, and that's why they have so many layers. Now, every architect knows there's no free lunch. Well, there's a blank spot on the right-hand side, and that is, of course, the downsides, right? Now, if anything comes in, it has to go through 4 layers or 10 layers or 20 layers, right? Anybody who works in a large organization knows that, has seen that, right? So there's runtime latency, and it leads to another very big problem. People will start optimizing within their layer, but we all know that a sum of local optima is not a global optimum. Right? You fall in the trap of optimizing locally, and the way you notice that is, let's say you want something from this department. They have a giant spreadsheet you need to fill out with all the information, because it makes the implementation more efficient, right? Because they get all the stuff they need in one fell swoop. So they optimize locally, but cause a giant cost in the next box that they don't see. Right? And those are, in the technical system, is exactly the same thing. Every developer knows, all I want to do is add a single field to my screen, and I need to make the change in the UI framework, the application server, the persistence mapping framework, the database, the backend service, the API, what else have you, right? All I'm trying to do is add one field, and I need to make a change in 6 layers, and it takes me forever. Every developer has seen that. And in organizations, that is exactly the same thing. Now, if you use your architect thinking one more layer, if you look at the stuff on the left-hand side and the stuff on the right-hand side, they're slightly different. It feels a little bit like one of these IQ tests, like what doesn't fit in this series of terms, right? So do take it with a grain of salt, but the things on the left-hand side and the right-hand side are different. The things on the left-hand side are more structural considerations, right? They're like bringing order, it's talking about dependencies, et cetera, right? It's talking about the static structure of it, the design of it. These things, almost all of them talk about the behavior, the performance, right? Latency, propagation, optimization, overhead. So the left-hand side things talk about static design, and the right-hand side things talk about dynamic behavior. And now we know how organizations became happy with layers in the past, because things were slow moving. And when things are slow moving, these runtime overhead considerations don't really harm you because it's slow. You have time, you have resources, right? So you enjoy the structural benefits. And as the world gets moving quicker and quicker, this starts to flip. And that's why we have the famous consultants speak of delayering, right? We're trying to take layers out, or we're trying to write the architect elevator, right? Because we're starting to realize that as the world moves more and more quickly, these runtime disadvantages actually come to bear more strongly and outweigh these advantages. And that is absolute classic architecture thinking, both apply to technical architecture as well as to organizational systems, right? And architects can do that. They're usually just a little bit too shy because organizations deal with people and all the other complicated stuff, right? So they rather still stay in their technical domain, but in the end, the forces and sort of the balance of this is totally the same. One last thing the architects in the Penthouse learn is that optimizing the pieces doesn't necessarily improve the system. So here's a classic example. How fast can these cars go? Well, pretty fast, probably almost 300 kilometers an hour. How fast do they go? 20, maybe 25, 30 if you're lucky. Now, the obvious question is, does putting more horsepower in the engine make a difference? Fairly obvious, no, right? However, if you look at many organizations that look a little bit like this, right, they go and say, oh, we need to hire better people. right? Which is exactly the same, like, oh, we need to put more horsepower in the engine, right? But in the end, it's not the people, it's the system that makes things go slow, right? And again, this is a very important architectural kind of thinking because it's easy to come in and say, well, you know, in this organization, nothing really moves, right? I'm sure these people, you know, maybe they don't work all that hard or, you know, maybe they're not up to date on the latest skills, right? And on closer look, you find out they're all actually Ferraris, right? They're just stuck in a giant traffic jam because the thing has a million layers, right? And it's all locally optimized. Each car is fantastic, but it's not globally optimized, right? Somebody needs to put some more lanes in, and to be honest, somebody needs to also teach them how to drive in lanes, right? Maybe that would help as well, right? So apparently purchasing power and driving skill are, you know, orthogonal dimensions. Coming to the mid-levels, right? Going here, thinking like an architect at the mid-levels, right? So now we're talking a bit more about IT, and there's a very sad message for most architects. Yeah, and it comes straight from the chief architect, and his people actually don't care about the architecture. Why do they not care? Because to be honest, they don't see it, right? Your users don't see your architecture, right? You have all these nice pictures on your wall, like people don't look at that. They just see whether your system is performant, easily maintainable, doesn't have any downtime, right? They see the capabilities that your architecture gives the system, right? And interestingly, those capabilities come from how the system is put together. Here we have two systems. They consist of the components A, B, C, and D. Yeah, easily illustrated here in this architecture, beautiful architecture diagram. And you know, we can easily guess that the system on the left-hand side and the system on the right-hand side has very different capabilities. Right? This is classic layering. It has a long runtime, but it's easy to take element C out and replace it with something else. Well, the right-hand side is exactly the opposite. I can go from A to D quickly, but if I want to deal with C, right, it has all these kind of dependencies. So they're basically exactly the opposite of each other. So that leads to a few insights. And the one insight is architecture without lines is meaningless. So if somebody brings you an architecture picture and it doesn't have any lines, you can say, hey, Gregor told me, well, without lines, this is not any useful. So I'll invite everybody to give that challenge to architects you have, right? If there's a picture without lines, it shows the ingredients, but it doesn't show how it's put together. And unless you show how it's put together, you don't know what the system behavior is. And you know what? The users only care about the system behavior, not so much about the ingredients, right? If you go to the restaurant, the menu has a list of dishes. It doesn't have a list of ingredients, right? Buying good ingredients is helpful, but you know, good restaurants buy nice ingredients, but mostly good restaurants are known because they have a great chef. So we need architects to be good chefs, not the guys who run down the supermarket aisle. Right? The architect needs to be the chef who puts things together in the right way, and that's what makes the good architecture. And that likewise means if you ask somebody who says, what's your architecture? And they say like Oracle, WebLogic, whatever, you also realize that that is not very meaningful, right? Because they're listing merely the ingredients, right? It's like, what are you having for dinner? Oh, I'm having grain and tomatoes. And it's like, well, what could you, like a pizza maybe, right? Or, pasta with tomato sauce or some sandwich, right? It could be many things, right? People don't do that. So don't allow your IT architects to get away with just listing ingredients. People want to see the meal, not just the list of ingredients, because that's what the users care about. Second one in our mid-level here that we have is the role of architects is often seen as dealing with the so-called non-functional requirements, right? We have the developers deal with functional requirements, they build the features, and then we have sort of the architects, right? There's the view that the architects deal with all the illities. So classic model, right? And most people have probably seen this. Now, I wish the life of the architect was that easy. Because unfortunately, or maybe luckily because it makes it more interesting, is the architects, in my view, much more deal with the non-requirements. Now, they're not called non-requirements because they're not required. They're called non-requirements because they're requirements that were never stated. Context, tacit assumptions, things that somebody knew or expected, but they were not written down anywhere. Somebody also expected this to run in the cloud, but they didn't really say that because they thought that's obvious, and then 6 months later, they think it's obvious that it needs to run in a hybrid cloud, right? All these kind of things that nobody actually ever really said or articulated. That's actually the main world of the architect. All right, so architects don't just deal with non-functional requirements, they also largely deal with non-requirements. Right? We need to guess, we need to understand context, we need to talk to the business, we need to anticipate, right? Those are all things architects need to do. Makes the job of the architect quite interesting, right? As I said, the elevator is quite an exciting place to be. Now, Christoph already, and I joked a little bit that half of Christoph's talk was referring to the previous talk, and the other half he referred to my talk, so he made his life a little bit easy. Now, very clever, right? That's how you get to be Geschäftsführer. Yeah, it's like you defer, you delegate, right? You delegate very nicely. So he delegated one topic to me, and that is the topic to explain how architects are selling options. Right, this is Black-Scholes, the guy's got like a Nobel Prize for economics for this, if I'm not mistaken, right? So pretty clever people. What is an option, right? An option is you acquire the right to make a transaction in the future at known parameters, right? So Allianz stock is like, well, 180 euros or something now. You can buy yourself an option to buy Allianz stock in 1 year for 200 euros, right? So you buy yourself this ability to make a decision in 1 year to buy the stock or not. Right? And obviously that has a value for a couple of reasons. The one thing is, well, when the 1 year comes, making the decision whether you want to buy the stock or not is trivially obvious, right? In 1 year, if you can buy a stock for 200, well, if the market price is 220, you don't need to understand this formula at that point to decide that if you can buy it for 200 and sell it for 220, you have money in the bank, right? So deferring decisions almost always has a value, because if you defer it, by the time you need to make the decision, you have more information, you can make a better decision. And therefore, these options have a value, and they also have a price. Now, there's a very interesting element in this formula. It's this little sigma. If you haven't noticed, there's a sigma square, actually, right? It's like double important. Right? It's like sigma square. It's like, well, right? And sigma square is the volatility, right? And as you can easily imagine, deferring a decision has more value the less you know about the future, right? If Allianz stock has always been 180 euros for all the 128 years they've been in existence, maybe the chance that it goes to 200 next year is kind of low. You gotta just assume it's the same as before. Versus if things are all over the map, right, deferring the decisions has more value, right? The more uncertainty you have, being able to defer and making the decision later is more valuable, right? So in volatile environments, option prices go up. Now let's translate that back into the IT. What is a perfect architectural option? A very great example of an architectural option is scaling out hardware, right? Everybody knows server sizing is kind of a difficult exercise because you have an application that needs some hardware and you're trying to guess how much hardware it needs. Now, life is sometimes a little bit unfair because you only have two choices in the end. Either it ends up being too small or too big, right? It's like, one or the other. If it's too small, the application won't run. If you put too much hardware, you wasted money. Not a very happy exercise. Now, what can architects do for you? They can give you the option to add hardware as well. We call that elasticity, cloud, scale-out architectures. Right? We have many names for this, like technical names. But what we're really doing is we're giving you the option. Now, this is great because once the application is running and you can see how many users are there, right? We deferred the decision. Making the decision is now very easy, right? So, oh, now I know how much hardware I need. Well, 2 more servers. Well, great, right? Oh, it's a little bit too many. Well, 2 servers less. Very, very easy. Now, coming back to our friend Sigma here, right? The friend Sigma is, of course, in the scaling example as well. If I'm building an application and it has only 10 users, if one gets sick, it has 9, fair enough, right? But basically, I know there's always 10 users for this system. Buying this option of elasticity and scaling isn't all that valuable, right? It's intuitive, right? Because there's little uncertainty. Versus if I'm building an online system where I have 100 users today and 100 million users the next day, and I have Black Friday and holidays and what all, right? You can imagine, there's volatility, sigma, right? You can see that this architecture option becomes much more valuable. And that's the nicest compliment I've actually received from upper management Allianz, the former head of asset management. He said, if architecture sells me options, I really like the metaphor. And he says, I know that the value of options increases with volatility. We live in very volatile times, both from a business and a technical environment, so I should invest more into architecture. right? So this is one of the nicest compliments you can get for being an architect. And who would have thought that that comes out of showing people a Black-Scholes formula, right? So the world is interesting, right? So if you connect many different dots, sometimes interesting things happen. Well, that brings us closer to the engine room, right? And there's a lot of stuff here, so I'm actually not going to talk about so many things, right? Because a lot of things going in the engine room, so I'm only going to pick out one or two things. Funnily, something that Christoph already talked about, but I think I have nicer pictures. So, because Christoph talked about, I'm going to make that cursor go away here. Because Christoph talked about, traditionally we build robust systems. Well, he had a whole talk about resilient systems. And to be honest, right, robust systems are not bad, right? We often need to remember that when we bring something new, it's easy to fall into the trap of saying, well, we made something better, and that makes the old thing worse. Architecture is not a Hollywood movie. It's not it's not the battle between good and evil, between right and wrong. It is just these things largely used to be good and often are still good, but they have certain limitations, right? And the things we do on top of it help us overcome some of those limitations. So building robust systems is not wrong at all. Who wants to build a flaky system, right? So making robust systems is good. They're basically built so that they don't break. The problem with robust systems is, of course, what happens if they do break. And I always say that's like a German car. I hope nobody offended here, right? German cars are built to not break. BMW is a fantastic car, but there it breaks and you have to take it to the shop, right? The bill is going to be very, very high, right? So that is robust architecture, right? Resilient architecture would be if you can more easily replace some pieces. So here it's about making things not fail. Here it's about making things recover quickly. And as Christoph already said, both are part of the same equation. You know, if you become really good at failure recovery, right? I actually have a lot of old cars, so I'm fairly good at failure recovery, right? Because they do fail a lot, right? If you're really good at failure recovery, if something fails a bit more often, isn't all that bad. If it's back up and running in 10 seconds, you know what? That's why I always have starter cables in my car, right? I just say a battery is dead, starter cables, so I become more resilient, right? That battery is no longer a problem for me. What's important to realize, though, is that these things are largely done out of the infrastructure. Better network, better storage, better servers, hardware redundancy, right? This is all done out of infrastructure. This is largely done out of the software. This is like middleware, software-defined infrastructure, containerized sort of auto deployments, right? This comes out of a very different world. And while these things always look so easy in the slides, you realize that for the people working on it, it's a massive shift, right? You have the poor guys in infrastructure battling it out because they're sort of feeling the last bastion of basically establishing uptime, not realizing that the other folks have a whole different logic of dealing with it, right? They've overcome the limitations, right? Basically, these guys are making thicker and thicker and thicker walls until there's no more room to live in. And the problem is if somebody comes with a bigger rock yet, it will still go through your big walls. And somewhere else, right, in the fairy tale, it's always behind the mountain or something, I think, right? Somewhere behind the mountain, there's people who just build differently. And that is a big transition. That's what we call transformation, right? It's not a linear extension. It's a different worldview, right? It's a different way of looking at the world because it has different tools. Now, once you're resilient, you can do something pretty clever. You can inject disturbance, right? And Christoph already talked this a little bit. If you can overcome failure very easily, injecting failure is actually not a bad thing. It turns out it's actually a good thing. Because more failure you inject, the better you become at this recovery, right? So these people actually intentionally inject failure. Now, careful, don't do that if you're here, right? If you only, you don't want to inject failure. So I always warn people, management read about the chaos monkey. So, oh, we should run the chaos monkey, right? Bad idea if you're in this kind of IT architecture, right? Because it's going to take all your stuff down, right? So these things have a natural sequence. But there's like a couple of great examples of these kind of systems. And again, it's not just hardware and application-based. It's really system-based. It includes mindset and people and the way you operate, right? It's another ballgame. Two great examples I have for injecting disturbance. What do the firemen do when there's no fire? Okay, they play cards and polish the trucks, right? But if they're not polishing the cars and their bumpers and playing cards, they set fire right? And here are some firemen setting fire. No, actually a pretty big fire. It's like a kerosene fire. They set fire, right? They inject disturbance in the system. They create failure. Now, they're doing this in the staging environment, not in the production environment. And that's okay, right? I have no problem with that, right? But they're basically injecting disturbance, because the last thing you want if your house is burning and the fireman comes up, oh, that's a fire. Like, you don't want, right? You want people who can deal with disturbance. And the other example, of course, is the human body. We do the same thing. We are a very resilient organism, and we get immunizations. We take shots. Right? Immunizations are injecting disturbance into our system to make us more resilient. Right? We are essentially also what we like to call anti-fragile. And I always like to draw these analogies. Right? Large-scale IT architecture is very much like the real world. I just feel somewhere along the line, the computer scientists have decided that because their stuff is digital, their world is different than the real world, right? Somehow they dreamt up that in our world, everything is always consistent and binary and transactional and all these kind of things. And you know what? In reality, it isn't. And trying to build a system that pretends it can be perfect in a world that is not perfect is never going to make you happy. So a lot of architects now realize that system architecture is much more like the real world. Stuff goes wrong, you know, stuff fails, things are unknown, things are inconsistent. But luckily, you know what? Because the world has been like this for a couple thousand years, we know how to deal with this kind of stuff, right? It's just like we need to get out of our 0 and 1 illusion. We need to get back into building systems like the real world build systems. So that was a pretty nice run through, you know, digital world, architects riding the elevator, right? Busting the illusion on the top floors, unfortunately, right? And riding down the elevator to the different levels. Of course, what we want to do is we want to bring change, right? The reason we ride the elevator up and down is because we want to influence how this organization works. And as I said, we can't just collapse it, right? So the next best thing we can do is connect it. Now, change is tricky business, right? And one of the biggest fallacies you can make is when you see an organization where things are slow and inefficient and maybe break a lot, you might just say, hey, probably it's pretty obvious people are doing the wrong thing, right? I know how it's done well, and I look, they're probably doing it the wrong thing. Doesn't work that way. Most organizations where things aren't working very well, each person is doing exactly the right thing. Classic example. So let's say you have an organization where there's high friction. Well, we all know friction. You need to fill out this other report. You need to make this request, another steering committee meeting, another budget report. We all know what friction looks like, TPS reports, right? So a lot of examples of friction. So if you have high friction, doing something costs more money, right? Because somehow you need to deal with all this stuff, your company, your business, nothing is free, right? Now, if doing something costs more money, what is the absolute right logical thing to do? Well, if you're spending more money, you should have more oversight and controls. It's the right thing to do. Well, you know how the story continues, right? If you add more controls, you're adding more friction to the system. So let's say, for argument's sake, that the minimum cost you can have for a project is 100,000 euros. And I'm not even thinking that is such an unrealistic number. If you're thinking to make a real proper project that writes one line of code and deploys it to the web server, hello world, we have all the overhead of applying for the budget, approval, security reviews, all that kind of stuff costs you 100,000. Easy, right? Some people might actually think, oh, I want to work there. So it might be worse, right? Might be worse. Are people gonna ask for 100,000 euro projects? Not really, right? Because they would be paying 100,000 euro overhead, right? They would be paying 100% tax. So what do they do? What is the right logical thing to do? You make $1 million projects, or better yet, 2 million, right? You sort of anticipate everything else you might want, you know, down the line, because you're already paying this project overhead, so why not make a bigger project? It's the right thing to do. And you can see how the story continues, right? Because now you have all the projects are €1 million projects. Now, €1 million is a lot of money, so you should have a few more steering committees and a few more budget checks and a few more reports, right? And you can see that every person is doing exactly the right thing, but in the end, the system is going into negative spin. Now, that leads to a couple of consequences. The nice thing is it also works the other way around, so there's hope. Right? So if you get things to be low friction, people help each other, they make smaller projects, yeah, so it works also in a positive direction. However, you need to first keep things from spinning the wrong way before you can get them spinning in the right way. And stopping it from spinning the wrong way is not as easy as saying, let me look who's doing something wrong, because you will find everybody is doing it right. So you need to fix the system, not just the pieces. And again, that is architecture, right? We all know this. Every system administrator knows this, right? You're looking at your monitoring, your system's monitoring, all servers are green, nothing is working. Right? It's exactly the equivalent, right? You look at the dashboard, well, all servers are up there, electricity, CPU is available, right? But the website is down. It's exactly the same effect. It is between the pieces where these kind of problems happen, and that's why architects deal with the non-requirements, right? This stuff wasn't written down on there. So leave you with a last message before lunch, and change looks like this. People are on a little hill here, and they're actually pretty happy on this little hill. Then you, as the highly qualified consultant or new hire, come in and say, hey, I am from consulting company XYZ or cloud provider ABC. I know a different world. I know over here there's a mountain of gold. Everything is better. On the mountain of gold, everything is fully automated. Everything runs in Docker containers. Everything is infinitely elastically scalable. You only pay for what you use. It's globally elastically load balanced, right? There's a mountain of gold. It's paradise. Milk and honey flows, right? Everything is great. Then you say, let's go. And then people realize, ooh, they need to get off the little hill, and they get into the swamp. Because people, their stuff doesn't run in a container, they don't know Kubernetes so well, maybe their own little network isn't so fast to connect to your global network, right? They're trying DevOps and being agile, but they get into a giant mess, right? It's like they all end up in this little swamp. And now you have a difficult problem, because people say like, you made it worse. And unfortunately, they're right, right? You made it worse for them because being on that little hill was actually better than going through the swamp. So that's why change is so hard. So you need to prove to people, you need to show to people that this actually exists, and you need to be honest to them that it actually will get worse before it gets better. Now, very smart people, of course, say, well, why don't we stay here? Life isn't actually so bad on our little hill. Well, there's one problem that's called the digital revolution, and the digital revolution is like global warming. Now, some people still convinced that doesn't really exist. Well, most of us have seen this, right? Global warming brings rising ocean levels. Well, things need to be faster, release cycles, global products, all that kind of stuff, right? The water level rises. And now, going from a little hill to the mountain of gold is no longer a swimming exercise, no longer walking through the mud exercise, but it's actually a swimming exercise. So I want to leave you with 2 words of wisdom, right? And the first one is, it always gets worse before it gets better. But the second one is, the worst thing only becomes worse, so you're better off going now. Thank you very much. Thank you. Thank you.
Well, thank you very much for this very inspiring talk. It is my honor now, before you leave for lunch, to present you a little gift of ours.
Oh, thank you.
So, to show our gratitude.
Thank you.
And
sorry. Where's the camera? Thank you.